We're going to spend the next 45 minutes exploring a new technology in the disinfection space, UVC for hard surface disinfection. So what we're going to lay out here will be about 15 or 20 minutes of an introductory overview, and then we have the distinguished luxury of having Miss Julie Jolly, the modern matron from Royal Manchester Children's Hospital, who has a good extensive experience utilizing that. So why don't we cue the video and then we'll go into a few additional slides.
Technology in healthcare is changing the way hospital
rays kill any other living organism left behind.
Hits every surface, and it also reflects off of the surfaces so that every nook and cranny is going to get hit.
Okay, well, that gives you a little bit of an introductory overview. I had told Julie I wanted to cue the smoke machines and kind of the dancing light and disco ball, but we thought we should keep it a little more professional than that. So maybe at the cocktail hour we can do that. But we'll spend the next few minutes just walking through kind of how or what that technology does, how it accomplishes it, and what its design and intended uses are. So we'll walk through a little introduction to the technology. We'll review some of our data and our evidence. We'll look at the physics and some of the science behind those design rationales and some of the features. We'll briefly touch on some of the applications, and really then I'd rather, quite honestly, hand it off to Julie to give you a real-world UK experience utilizing the technology. This has been in the news. It's been widely kind of publicized. It's being adopted in varying degrees across the globe. In the U.S., it's becoming very widely used. I think it would be a stretch to say it is at standard of care, but UVC disinfection, just at the recent APIC meeting this spring, was very much focused on. And Dr. Ritala, who many of you may have heard of or know, said this technology should be used for terminal room disinfection. If you don't have it, put it in your budget. It should be used. And we just haven't heard that strong of a position. I also want to be cautious. We're not here to say this is the silver bullet. We see this as one of a comprehensive toolbox. UVC is something that can be ancillary, supportive, and very conjunctive in conjunction with antimicrobial stewardship, hand washing, hygiene, all of your other good strategies. But what we've designed this for is first and foremost for the safety and the benefit of the patient. It also benefits the staff, and which benefits the community, which leads to a cleaner environment, and it kind of does this circle of care within the healthcare environment. Like with any other technology, it requires protocols, it requires labor, and it requires some processes to maximize its effectiveness. But there are many that are starting to do so, and even we, when we commercialized this solution just over 2.5 years ago, we continually learn even from Julie and other new customers as we go along. So let's frame up, why do we even need this? About 50%, and that's on a good day, of the high-touch surfaces after disinfection are not adequately disinfected after a terminal clean. It's in the literature, and it's widely kind of recognized and reported. It's not without effort. It's not without trying on the environmental services. There are more and more fomites and technologies in the room. There's just more surfaces, and occupancy rates are at an all-time high. So the fervor for discharge and kind of another patient also only adds to that stress. We like to try and keep it within the realm of the known and the data and evidence, so we're going to review a little bit of that, but that starts with the role of the hard surface environment. It's been proven, and it's widely known that that can play a role and act as a vector for the contribution of HAI. We know a lot, and I put Dr. Otter here and many others, that we know that there is a need for disinfection and for the environment to continue. We also, and maybe this wasn't so widely known, or maybe it was widely known but not as widely accepted until the recent past, but UVC has virtually, it's factual. It has been proven. It is germicidal all the way and up into being able to tackle C. diff in its spore state, which because of its physical composition is the highest kind of degree of challenge or has the highest resistance to UV radiation. But it is fact that UVC is germicidal. The thing that's unique and different about our Surfacide approach is that we've tried to tackle some of the limits of some of the first generation systems, and those were namely shadows and distance. By having a single emitter, there's just no way without multiple repositions that you could not address the shadowing. And if you move it several times, it's an inefficient use of labor, and it adds to the time between the room turnover. So our design rationale was to use multiple emitters in a single automated cycle. There will be 3 emitters. They're communicating via Bluetooth and controlled by a remote tablet. And because we have 3 in the room, we can triangulate and deliver more light and energy, really is what does the disinfection, from more angularity. What we also, maybe not as intuitively do, is because there are 3 assets in the room, we are closer to more surfaces, so the intensity of the energy is greater. And I'll talk a little bit about that. But it really comes down to doing the job, delivering total energy to be effective, but with less labor and in less time. We've, as I mentioned earlier, been on the market in the world of just over 2.5 years. There's about 125 institutions that have adopted the Surfacide multiple emitter strategy. It's a little bit of a brag board, but what I like to also talk about here is that we get to learn and collaborate. So when we get to go into some of the leading hospitals, including RMCH here, we get to learn together. We understand frustrations, and we can adapt and adjust our technology and the protocols as to how it's rolled out so that it's better for our next customer. And we all learn together. We're very collaborative. Let me walk through a real quick data. This is really just a kill study. This was at Georgetown in Washington, D.C. The blue bars represent a post-terminal clean microbiology swab, and you can see, like the data indicate, there was a residual colony-forming unit count. We then ran a cycle with the Surfacide in these large single patient rooms. They were very large. The average cycle time was 19 minutes. And you can see that we target around a 3.5 to 4.5 log reduction, and in this study that was achieved. While we do recommend terminal clean, The Ohio State University in Columbus, Ohio is one of our alpha centers, and they've been working with the technology for more than 3 years and seen its power, and they really wanted to test its limits. And this was presented at Shea last year, and you can see this was without terminal clean. So it demonstrates the ability of the UVC energy even absent terminal cleaning, which we don't recommend, but it demonstrates that it still can have a significant logarithmic reduction. This one study here is from upstate New York, and with the Affordable Care Act and other healthcare reforms in the United States, we have an increased reporting and an increased penalty structure of fines and diminished reimbursement on preventive outcomes, including healthcare-acquired infections. Mohawk Valley was one of the worst. It was actually the second worst hospital in the state of New York, and they implemented Surfacide. And the good thing about this study for comparative basis is all other things were held constant. In many of the literature reports that you'll see about UVC, they were in conjunction with a new hand washing hygiene or a new quaternary cleaner or a new antimicrobial stewardship. All of those were held constant. There had been no previous changes to those in the previous 6 months, and we monitored for the next 12 months the first initial 1 year of use of Surfacide, and on C. diff they realized a 41% reduction. Now, I realize our American costs are out of skew, but even putting that into context, in just the C. diff, in just direct cost, in just the first year, the hospital offset $1.4 million with that 41% reduction. We also are trying to keep ahead of kind of the evolving world of what could happen. We know, for instance, when the Ebola crisis hit a while ago, we can demonstrate efficacy against Ebola, and while MERS has not made it widely onto our shores and has been mainly a Middle East phenomenon, we were able to study this recently, and this was accepted and published in Itchy, and it shows a dramatic effect. The virus is widely susceptible to UV radiation, showing a 6 log reduction after just a 5-minute cycle with UVC. So we're going to continue to try to evolve that. Let me tell you a little bit about it. All UVC is virtually the same. Our company did not come up with or patent some magical recipe. There's not some crazy spectrum that's going to save the world from all the superbugs. UV is UV, kind of just like water is H2O in New York as it is here in Manchester. We chose to use and deliver continuous 254 nanometer UVC. While dead is dead, it really doesn't matter. The reason we chose 254 is it's the peak of the germicidal effect, so it's the most efficient. It will get there soonest. So the more energy that is at that spectrum and that wavelength, the faster that the radiation will have that germicidal effect. It also, it's very important as we learn and as you look at UVC or consider it, it's really a pretty simple fact that total delivered energy correlates to the logarithmic reduction. It's about total delivered energy. The more energy you deliver sooner, the quicker and the more high the kill will be. The less energy delivery, the lower the logarithmic reduction. And there's plenty of studies to show that. What a lot of the first generation, or what you may have seen in the literature, and even some of the ones that are single emitters, they just grossly underestimate the amount of energy that is required to be adequate, particularly for C. diff. The vegetative, those are relatively, you saw the virus in the MERS study. However, particularly the spore require far significant and greater energy levels than many of those are capable of delivering. And we learned this the hard way. Our target is to deliver about 1,500 millijoules per centimeter squared to every surface in that room. And we learned that because we were trying to target not doing or doing less than that, and we measured the kill and it wasn't adequate. It didn't meet our target for a 3.5 to a 4.5 log reduction for the technology. So we continually ramped it up until it reached a successful spot, and that was far greater than many of the previous reports. So we talked about shadows. Let me show you a video here which just shows you, it'll be a little bit of a comparison. On one side, should be, let me try it again. I guess we're not going to see it. Let me go back to this. So on your right side, you can see that the single emitter would require a reposition. In an individual patient room, we'd have to start in position A where that is. It's not near enough in proximity to many of the other areas, including the bathroom, so we'd at a minimum need to move that into the bathroom, and then at a very minimum we'd have to move it in to where our position C would be near to this side. And even then, because of the intensity and the diffuse energy, it would not nearly be done so as efficiently. It also would require labor. So it would require a human being babysitting that and moving it from position to position, which will also then translate into a greater cycle time. The other thing that is important to consider is the effective distance, and that goes back to your physics, which is the inverse square law. Every time the distance doubles, the energy isn't merely cut in half, but it's the inverse of the square, so it's 1/4 the energy intensity. Another way of stating that is every time the distance doubles, the time goes up by 4-fold to be able to deliver the same amount of energy. So we take advantage of that distance by keeping more objects nearer to the emitters. We target a 2-meter distance. In most room spaces, we're able to do that with our 3 emitters in that room, and we can then do so efficiently. Let's see if this one works. Nope. One of the things we also do, it may show up here, is we begin each cycle by measuring the actual dimensions of the room. So we use technology to leverage the advantage of learning where and how big this space is, and it will adjust each room to room. By learning the space and the volume of that room and learning the layout of that room, we can calculate accurately with our algorithm the amount of time that that cycle needs to run so that we're always assured of delivering the 1,500 millijoules per centimeter squared. So not only do we automate the measurement and calculation of that time, but every time our cycle runs, we're continually measuring the total energy delivered so that the calculated was actually met and validated. While it could be a potential downfall of a multiple emitter system, we've been the winner of a number of kind of innovations and designs for how the system integrates and how it works. One of those is around our portable efficiency. The system utilizes motion sensing for safety precaution. It utilizes a tablet and a warning standard outside of the room, and those then recouple as links to join the 3 towers together so that they very easily move and can be transported throughout the hospital. And that's Colleen sideways and upside down. So takes about 15 pounds of ergonomic force. See how great she is going downhill? She's really, really good at that. It's pretty good that you can control it that well. So let me talk a little bit and then we'll move on to Julie, which is really what matters. There's really not a space within a hospital that this is not potentially applicable to, but where it's most widely used is in the ICUs and in the isolation discharges. Virtually every one of our about 125 hospitals globally are using it in those applications. Many are using it just upon normal patient discharge. A lot of our hospitals are using them in operating rooms or in the theater, whether doing dailies or when they do the deep cleans weekly, many of the operating rooms. And an operating room presents a unique challenge to UV. One, the rooms are very large, and two, there's a lot of equipment in there. So by utilizing our multiple emitter technology, we're able to accomplish that very efficiently. One last unique thing, and maybe we can talk about that later. I hope many of you have questions for Julie, but because of our laser that is integrated and because of our parabolic concentrator, we are also able to handle multi-bedded bays and smaller spaces. While an individual emitter that broadcasts energy out in every direction, you could not contain or control that energy. Because of our lasers, we can align it and choose and designate a fixed disinfection space that's very specific, and it does not deliver radiation to the surrounding patient or the staff in any unsafe way. It can be contained around the patient area. The system can also be decoupled. While it's designed to be operated in tandem in most spaces, in daily cleans of the bathroom, in other small closets, in equipment, other disinfection, it can also be decoupled, and each can be run as an individual emitter depending on the application. We also, where there is the presence of multiple systems, can join multiple systems together, and they can be connected for large space disinfection. This depicts a little bit of the scrub, so if you will, and imagine that that is contained maybe an ICU or a multi-bedded bay. Our 3 towers would merely disinfect between those endpoint and start points, and they would oscillate back and forth. And over about a 7 to 9 minute cycle, we can deliver upwards of 2,500 millijoules per centimeter squared to the center of that patient bed. So it's a huge dosage of energy for disinfection. Another thing that many are doing is disinfecting keyboards or workstations on wheels. We can use the scrub cycle to disinfect a wall or a shelving unit with other equipment on it, and many are doing so daily. The last and final thing I want to touch on is not only can it accomplish this, but with our Wi-Fi and our cloud portal, we are able to send all of that data up into the cloud for monitoring and reporting. We give you a very, very easily accessible, just at our network and onto our cloud, you can custom tailor a portal that will show where the work was done, what some of the average times, the total energies by user, by space. If you can do a pivot table, you can very easily drop and drag, and all of that is exportable. We also are happy to connect. While we're based in the Midwest, we are happy to connect, and we have a global training center where we do a lot of live webinars where we can walk through kind of how the technology works and show in about a 5 or 10 minute cycle, you can see how it actually works as if you were in the room. We do all the manufacturing in Waukesha, Wisconsin, which is just north of Chicago, just outside of Milwaukee, Wisconsin. And that's where all of the manufacturing is carried out. So I want to get it to Julie, that's more important, but I hope you've understood how we address shadows, how distance plays a huge role in delivery of total energy. It's about being efficient with your labor. While you probably are looking at prices of equipment and thinking the technology, the hidden cost is labor. over the use of a technology of 3 to 5 years, the people cost and the human cost will far outweigh the technology cost. And we are about making you efficient, but really we're in healthcare to help people get better and improve lives. And we know that that takes total energy delivery, and we can play a big role in helping with environmental kind of sourcing of HAIs. And for that, I'd love to have Julie Jolly, the modern matron at RMCH here in town, talk about her experience.
So my name's Julie Jolly. I'm the matron of the Royal Manchester Children's Hospital. About 12 months ago, one of our areas was having some problems with some of their health-associated infections. It was an oncology unit. Obviously, oncology unit, there's lots of patients there who are very high risk. This is our children's hospital here. We're not going to look at any slides. It's a new hospital, so you'd expect it to be relatively clean. But like every other hospital around the country, we have the same issues, the same problems that everyone else has with infection control. We have really good protocols, guidelines, policies in place. Our hand hygiene is really good. Our uniform policies are good. Our bare below the elbow, everything really, really good. But we still have areas where we have problems with the health-associated infections. And in particular on the oncology unit, staff there were becoming really, really demotivated because as far as they were concerned, they were doing everything possible to protect the children, protect the patients that were coming into the hospital, and yet still health-associated infections occurred. So they embarked on looking at different ways outside of what we were currently doing to see if we could improve those outcomes. One of the things that we decided to look at was the use of UVC. And that's how we actually got in touch with the people who developed the Surfacide unit. They agreed to allow us to use these machines for 8 weeks while we did a pilot on the oncology unit to see if it actually made any difference. So the machines arrived and everybody was really excited because, as you've seen from the video, they look quite high-tech and you'd be rolling them around and people would be saying, "Oh, what are them?" But anyhow, the machines arrived, staff were trained to use it. Training took all of 5 minutes per member of staff. It's that simple to use. And we decided that we would roll out using this in a very proactive way. We took a whole ward and we categorised the ward into 3 areas, a high, medium and low risk area. Areas that were high risk were the bathrooms, joint care areas that had a lot of throughput, and obviously the children's rooms themselves, cubicles or bays. Medium areas were things like, at the time, parent rooms, clinical rooms, where obviously mainly nursing staff, not patients, would be going into them. And then obviously the low risk areas were the more communal areas that were up and down the corridors. And the idea being that high-risk areas, if it was a patient room, they would obviously be cleaned using the normal cleaning processes that we have following our current infection control policies. And then afterwards, we would go in and Surfacide them. That obviously, if it was a patient area, would be done as the patient was discharged. If it was a bathroom or a toilet that was classed as high risk, because obviously it was a communal one, then that would be done on a daily basis. For medium areas, it might be weekly, and the low-risk areas would be monthly. So we instigated a programme for the ward, and we started in May 2015 with the pilot. The pilot ran for 8 months, thanks to Surfacide, who allowed us to keep the machines, because what we found in the first 8 weeks was that although we felt we'd made significant difference and we felt better, and the staff on the ward who were using the machines actually felt they were making a difference, we didn't have enough data. We spoke to our infection control team who wanted us to actually do some research on this because, as you've heard, there's lots of research out there, but it's all come from America. There's nothing based in there wasn't anything in the UK that could actually show the evidence behind using UVC in a proactive way in a hospital setting. So we then embarked on doing a piece of research. We had our microbiologists, we had our infection control team, we had an outside laboratory help us do that. And we did the research. And the research actually showed exactly what the American research showed, that by using UVC, you can actually get up to 40% reduction in the count post-clean using UVC. And the paper is out on the tables outside. I'm not going to go through all the data because I think you'd all fall asleep. But the evidence is there to show that using the UVC actually does have an impact. Also, what we found on the oncology unit in particular was that over the 8-month period that we used the UVC, not only did we not have to have any deep cleaning with any chemicals, we also found that we had a 43% reduction in the number of health-associated infections that we had in the previous 8 months. Maybe that's just coincidence. Maybe it is because of the use of the UVC. We've used it in a very, very proactive way rather than a reactive way. We've kept up with all the other health infection control techniques that we have in the hospital, with the one exception being that we haven't done terminal cleans when we've discharged an infected patient. And our evidence is still showing that we have that reduction and there's less organisms in the rooms when we've actually used the Surfacide. The staff themselves have found the machines extremely easy to use. They add anything from 10 to, if you've got a really, really large room, anything from 10 to 40 minutes onto the normal cleaning schedule. If you compare this to a room that has had a contaminated patient or infected patient in, where you have to use a chemical clean, that can take up to 4 hours before that room is actually usable again. So there's also the impact on the actual bed turnaround for your hospital, which obviously turnaround equals money. So your actual turnaround and your patient throughput is actually improved greatly by using the Surfacide as well. Staff, obviously they're using it in a ward environment. Parents are seeing that machine pulled out. They see the nursing staff using it all the time. Parents are asking questions. Parents will ask what it's all about. Nursing staff are telling them what it's about. And the actual confidence that the parents have actually gained within the use, actually seeing these machines being used on a daily basis has been absolutely phenomenal. And some of the comments that we've actually had from the parents has been really, really positive as well. And that's actually grown confidence in us as a trust from these parents who, at the end of the day, are in a very, very high-risk area. And I think it just gives them the confidence to know that we're doing everything possible to be able to do this. It's not all been plain sailing. There has been some issues with it. Obviously, this is a new system. It's not generally used in the UK. And we're now at the point where we're actually going down the road of implementing it throughout the whole of the hospital. We are a very large hospital with quite a few wards and areas. We cover lots and lots of different specialities. And to implement something like this across the hospital to be used in a proactive way is quite a big project. So we're actually starting this month actually, we actually start our Surfacide project to actually implement it across the whole hospital. We're working with Surfacide and their partners here in the UK to actually make sure that it can go through on NHS frameworks. And unless you work in purchasing, you won't understand what all that's about, just the same as I don't. But basically, it's how you can actually pay for it. As I said before, we have done a pilot, we've done research. The information from the research is in a leaflet outside on the table. The actual poster from the pilot study that the oncology ward is on the door as you came in. Please have a look at it if you're interested. And our details, the same as Surfacides, are all on there if you want any more information on how you could possibly use this in your hospitals. Thank you.